welcome back to Prague. I hope you had a good lunch, and I'd like to start off this afternoon's session on land use change, and forestry by, I guess, Marketa, you can introduce the expert who will be providing us with an overview of that sector.
Okay, so the next presenter is our expert on LULUCF, Emil Chinchilla, and yeah, we can see him right now, and
There he is. Good.
I will give a floor to him right now.
Okay, thank you very much for giving me the opportunity to talk to you. Greetings to Skopje and Macedonia. I'm really happy to see that there is such a large and competent team involved in the reporting. I think you are not any beginners at all. You need a lot of competent people in your team. I have seen, I think, 3 full professors from Faculty of Forestry involved, and not speaking about the others. So I'm looking forward to exchanging our views on the inventory. So I'm going to speak on behalf of our small team, which is, I think, smaller than yours. So this is on behalf of our LULUCF expert team, and I'm going to talk about the sector land use change and forestry, not so much about Kyoto Protocol activities of LULUCF, because I think you will miss them, fortunately for you, because Kyoto Protocol reporting will end with the next UNFCCC submission, so it may not be relevant anymore for you. So, do you hear me? Can I continue?
Please go ahead.
Okay. So let's see if I can progress with slides. Yes. So this is a brief outline of the agenda that we prepared for you. First, a small introduction to the sector, and then I will talk about land use representation and land use change identification system that we implemented in our inventory, and go speaking about emission estimates by land use categories, and then briefly about QAQC in the sector of LULUCF, and then we can open questions and discussion. So this is our current estimate of emissions for the sector, for the entire sector, since 1990 to 2020. These numbers have not been reported yet, but these are our preliminary numbers that we have so far. So you can see that there is some dramatic development towards the recent years when the sink turned to the source, and this is due to the catastrophic development in the Czech forestry with drought-induced park calamity that really spread across the entire country, and makes the forestry to cut much more than the increment. So, but I'll come to that later. So when we look into our most recent submission, then we can say that within the LULUCF sector, we have 3 key categories, and you certainly know what key categories are. These are the most important, most significant categories of the sector by either level or trend. This is the abbreviation: level assessment, trend assessment. This LE and TA. And you can see that, of course, remaining forest land, this is the key category that contributes to the total greenhouse gas emissions by 11% in 2019. because this is the last year reported in the submission of 2021. And then second key category is harvested wood products with the share of 1.1%, and also land converted to forest land. That big, but it's still significant, 0.4%. So you may have visited Czech Republic, so you know how the country looks like. We included just this overview of the Czech landscape. We have mountains on the borders with the country, and then lowlands in the middle of the country mostly. So there are all kinds of land uses included in the Czech landscape. So we have to solve for all IPCC land use categories when we do the LULUCF inventory. As you may know, the most fundamental issue of the inventory of the land and forestry sector is how to represent land areas. This is really very critical task, and when you solve land areas in the sector, you will solve half of the entire inventory, because this is quite difficult when you have to collect data on areas and land use and land use change for the entire reporting period that spreads from 1990 to nowadays. So you know that 1990, it's almost archaeology, as I used to say, because usually there are no reliable records for this, and so one has to resort to different methods how to obtain the land use area data. But these are precondition for solving emissions. So representing land areas simply is the key task for the LULUCF team. And I think I can proceed further. So hence also it is very important to decide what data use for the land use and land use change system in the country that could be used. And we are fortunate to use the resources of Czech Office for Surveying, Mapping, and Cadastre. This is kind of difficult name, but simply this is the governmental office that collects all data on land use. So I can call it through my presentation as cadastral office. Simply governmental body which collects all kinds of data, and these are kind of official information on land use in the country. So this is our source for land areas. So we don't use any remote sensing products for land areas, because we believe that this resource that we have at hand is reliable enough, and it represents the official land use. It may have some disadvantages, but it has also some advantages, and we can discuss that later too. So entire land identification system is elaborated at the level of so-called cadastral units. These are small units spread across entire country, and there are about 13,000 of them. So basically there are some tasks how to actually elaborate that system. First we have to get the source data, then we have to link the country specific land use definitions with those of IPCC. We have basically in the country 10 specific land use categories that we have to convert to these 6 known IPCC categories of LULUCF. And based on that, we can work with identification of land use change and basically do the entire time series. And due to some methodological requirements, we have to also collect land use areas 20 years ahead of the first reporting year, which is 1990. So 20 years back is basically data since 1969 that needs to be collected to really properly build the entire time series that is required for the reporting. And this is all what we obtain from the cadastral office. So this is a slide that shows how we do the second step, that is matching country-specific definitions of land use to those of IPCC. So there are some categories that belong to cropland. These categories are arable land, hop fields. Hop fields are important because this is product needed for producing beer, and that we are the most heavily beer drinking country when you speak about drinking beer per capita. Vineyards, this is also a category under cropland. Gardens, orchards, and then we have category of grassland that belongs simply to grassland 4C, basically the code for the grassland. Forest land, of course, this is forest land. This is easy, and water areas are then linked to wetland land use category. And then we have so-called built-up areas, country yards. This is clearly settlements, and then we have other land with subcategories of waterlogged areas that belong to wetlands and unfertile areas that we assume represent other land. But what we do, we simplify the system of 6 land use categories by including other land subcategory into settlements, because we believe that basically all land use can be affected by human activities somehow. So simply to simplify it, we include 5F into 5E. So in practice, we report 5 land use categories. So this slide shows basically one example of so-called cadastral unit, KACOV. This is the ID of it, and it shows the data of subsequent years 2010 and 11, and the extent of all these IPCC land use categories. And you can see that these categories either remain constant, such as the example of wetlands, or may change. Either they decrease or increase. So this system basically determines the land use change within that cadastral unit, and all kinds of conversion types which are summarized in the table. The area is given in square meters, so it's pretty detailed system which gives you the all conversion types: forest land to cropland, forest land to settlements, cropland to settlements, grassland to cropland, grassland to settlements, settlements to cropland, and that all should somehow match. And we solve this land use conversions for entire system of, as I said, about 13,000 such cadastral unit. So it's I think it's pretty detailed. So then let me switch to another slide. All that is then summarized into mandatorily reported cross tables of land use change, which you have also reported in your inventory submission, as I could see. So you could see, for example, for the first year of 1990, how these categories change since during 1990, basically, because initial state is 1989, and then conversions during 1990. So these are initial areas down on the line, and then final areas in bold letters, and the same matrix of land use categories in 2019. So it's all composed from bottom up. That is summarizing these land use changes from these 13,000 cadastral units. Graphically, it looks like that. The country is divided into these small units. So these cadastral units are displayed here graphically, and the mean area of the cadastral unit is 6 square kilometers, and you can see the distribution of these units by area that they represent. And this is used to identify in space, geographically in space, for example, land use change at the level of cadastral units. Here, this is the example of deforestation that is used for Kyoto Protocol reporting, but basically you can display any type of land use conversion for any year during the reporting period using that system. So I think it's an example of geographically explicit representation of land use and land use change that can be used using that system. Okay, let's summarize how it looks like during the reporting period. Basically, not only reporting period, because here this slide shows our major land use categories. You can see other land, there is nothing there because the small fraction of other land is included within settlements. But basically, you can see development of land areas since 1970 up to now for all these major categories. So there is some slight increment of forest land constantly. Then we have a decrease of cropland. This is the most significant change. And then some trend in grassland and very small increase of wetland area, and of course increase in settlements. So this is again summary, the first year, the base year that we have in the Czech Republic, and the most recent year, 2020, and the differences. I think you don't need to remember these numbers, but simply cropland is the most significant spatially significant change. We have decreasing cropland area on account of other categories. Let's move from land representation to methodologies. Basically, we have to follow IPCC guidelines, 2006 IPCC guidelines for national greenhouse gas inventories, and also partly KP supplement. This is mostly for KP LULUCF activities, but not only for them, because there are some improvements in them. And then we have also 2019 guidelines, which I don't list here because we have not implemented much from those. And then we use some national studies, and most of our approaches that we apply to, at least for key categories, are tier 2 or 3. And you know that the tier 2 and 3, these are the more let's say, advanced approaches that use country-specific data or modeling. And so we try to use country-specific activity data and factors to maximum extent possible, and of course follow the advice and recommendations from the reviews that we undergo almost every year. So I will go quickly through the entire emission inventory system in terms of methodologies that I use. This slide is a bit complicated for you to maybe follow, but maybe you get our presentation so you can see what's in it in detail later on. They are basically those 5 or 6 categories, basically 5 land use categories if we don't speak about other land that is merged within settlements, and then the contribution of harvested wood products, which is not land use category but specific category that is also mandatorily reported in the LULUCF inventory. So and then under it there are details of emission estimates that we have in the inventory, and also for some categories estimates of nitrous oxide and methane. So let's go to forest land, which is, as I said, the key category, the most important category of LULUCF, because basically this is management of carbon in large extent. Forestry is nothing else than basically forest management is nothing else than managing carbon in a simplified way expressed. So you can see that this is again forest area expressed graphically in form of its share per cadastral unit. So the darker color means more representation of forest in those areas. So the most dark areas are those at the borders. So these are the forested areas, and then the light blue areas are those where forest is less represented. You may have heard about, or I also noted at the beginning that Czech forestry currently experiences a huge drought-induced bark beetle outbreak, which results in decaying stands, mostly coniferous stands of spruce and pine. So basically, our forestry is heavily involved in discussing how to adapt our forestry to convert it into more resilient, more adapted stands that would not be so sensitive to drought and temperature increase that is actually awaiting us. So this is just a symbolic example from where we should go, basically creating more diversified, more species-rich, more stable stands that will secure not only carbon fixing but generally functioning of forests, fulfilling all services and functions that are expected from it. So as for the peat category, you always face the question of what basic method to use, and you know very well that we have two major methods used for quantifying, assessing carbon stock change. And the first one is the default method, where we solve increment minus loss, and the second is stock change method, where we take stock of carbon in time 1 and 2 and take the difference divided by the time period for it. So these two methods have some advantages and disadvantages. Generally, stock change is considered sometimes being more exact, but it has the disadvantage of not exactly actually specifying what is the member of increment and what is the member of loss. So stock change is mostly used in connection with statistical forest inventories, whereas the default method is used when you have other data sources available. But this is not always the rule. For example, Finland, which is one of the Nordic countries with most oldest basically inventory system, use increment and loss to the default method in connection with statistical forest inventory. So it depends on the country what it prefers. Both methods are equally recognized and allowed for reporting. In our country, we have to look what kind of source data we have available, and basically the first and most important data that we use for inventory is still so-called standwise inventory, or data from forest management planning, because forest management planning is basically mandatorily required for all forest stands. So all stands have some plan, either more extensive depending on the area of forest, or at least some simplified planning or simplified plan for small areas or small forest owners. But basically, this is Forestry Act or Czech forestry law that requests that we have forest management plans, and it means that we have data on forests that are updated annually, or not annually, but on decadal basis. And when you collect this data for entire country, then it's updated annually. Of course, with mean delay of 5 years, but this is something that we deal with. So this data still represent the official source on forest data in the Czech Republic. So these are the data that you can find at FAO database, etc., or somewhere else. And then we also have National Forest Inventory that is sample-based, so statistical forest inventory, as we say, where data are collected using data sampled across entire forest area in the country. There are about 14,000 of them. And the Czech National Forest Inventory, the statistical one, already had its two campaigns, one in 2001, 2004, and the other 2011, 2015. So there are two basically time spots within the reporting period available with the National Forest Inventory data, but these data still do not cover entire reporting period, and we still wait until this system will be delivering annual reports, and this is something in preparation currently. So far we don't use much that resource because it's not fully adequate for our reporting. We can come back during the discussion to this topic if you would be interested in this. So, as I said, we mostly base our inventory on these data, standardized inventory from forest management planning. So, what we do with those data? We aggregate all these data into so-called three species group that define the ecology of these stands. So, this species group concentrate around major three species that we have in our forestry. That is beech, which includes all broadleaf trees or species except oaks. Then oak is a specific category that includes all oak species. Then we have pine, which includes all pines and larch, and spruce, which is conifers except pine and larch. So simply 4 species groups that are expressed per age class and area for entire country, and this is the basis for the recalculation. We have these data collected by Forest Management Institute. This is the data source for our data. This is the official information source on forestry, let's say, in the country. And this institute also conducts this National Forest Inventory, the statistical one. And here there is a note on these 2 campaigns that are available. Apart from this data, we also have data from the Czech Landscape Inventory, CzechTerra, that we conducted in our institute. These are also 2 campaigns, and this data we use also for, let's say, deriving some biomass expansion factors, and some we use them for some information that is not collected by National Forest Inventory. For example, data on forest soil carbon stock or litter. Then we also use Czech Statistical Office because this is the official source of information about harvest, and this is the second key term in the key equation that I showed you when we use the default method that requires the increment and loss, and loss is represented mostly by harvest, of course. So Czech Statistical Office, national body that collects the information on harvest from our forests. So this is how it may look like. Here we have information on areas grouped by 4 tree species groups. And for these areas, we express all the required data that are needed for the calculations of carbon stock changes. So then I'm showing you the graph of annual harvest, and this is the CZSO is the abbreviation of the Czech Statistical Office, which is the source of harvest loss that we have. And this harvest is also distinguished by being either planned, which is something that we know in forehand from plans how much has been planned and logged during individual years. And then the red part of the bars is salvage logging, and this is something that shows you the severity or extent of disturbances by calamities that we have. Salvage logging is that part of the harvest is or required development of disturbances in the country. And the Czech Forestry Act requires that every owner first salvage logging, and only then he can the rest perform in the quantity of planned harvest. And you can see that in the most recent years, when we compare the harvest with the increment quantity, which is the blue line that I am showing right now, so we can see that the harvest significantly exceeded the increment line. So of course it means that when you balance these two major terms of increment and loss, then it cannot result in anything else than emissions for the last 3 years. So additional example of data. Here you can see, I'm not sure if you see the slides sharp. On my screen, the slides are not sharp, but kind of distorted. But hopefully in Macedonia you can see it sharply. So I don't know what's going on with the presentation, but hopefully you see the slides correctly. Here you can see the growing stock by age, which is required for the calculation for these 4 major tree species. And similarly, we have biomass conversion expansion factors applied for the fraction of the growing stock depending on its age simply. So the calculation itself on forest land includes calculating or assessing carbon stock change in the following pools. It's the living biomass, dead organic matter, which includes dead wood and litter, and soil. And then I will also mention that we use, in this year, we are trying to implement assessment using a model called CBM, which I'll mention later. And then forest land also includes other sources of greenhouse gases, which are represented by prescribed burning and wildfires. And I know that in Macedonia you had huge fires, so for you it's also important category, but I will not be speaking much about the wildfires here. We don't have many of them, but we of course estimate also wildfires using the IPCC methodologies that are kind of standard. Then there is also a category of land converted to forest land, which is 4A2, in which we estimate carbon stock change in the same pools, that is living biomass, dead organic matter, and soil. And also this category we try to simulate now or estimate using the modeling tool, which would be representing a tier 3 method. This is the slide that shows the model that we currently are heavily busy with, I would say. This is a Canadian model which has been ported to European conditions at JRC, and we use the database that has been partly prepared there and adjusted for the Czech conditions, so that we implement Czech biomass conversion factors and data that are simply Czech specific into this modeling system. So we believe that we will be able to report for the near 2022 data that will be assessed using that model, but we will compare these assessments with the tier 2 estimates that we have been reporting until now, until the previous submission. So both tools are relevant. So this is forest land, I guess. This is the resulting slide for forest land showing the total emissions estimated so far for forest land. As I noted, it turned from the thing of about 5% during 1990 to 2014-15, and then since 2018 through 19 and 20, we will be reporting emissions for forest land that is expected to be a sink, but it's not a sink anymore, but it will be a source. Let's move to cropland, which I will take less detail because it's less quantities involved. Although this is the large use land use category in the country, I told you that it's decreasing. So we have currently about 40% of cropland in our country. So again, this picture shows the representation of cropland by these small cadastral units, and let's proceed to data sources that we use. So land areas, again, Czech Cadastral Office, Czech Office for Surveying, Mapping and Cadastre, that provides data on major categories that belong to 4D1. So also subcategories, the gardens, hop fields, orchards, vineyards, and this data are all registered at the Cadastral Office. So they are annually updating these data and passed to us. So this is official source of land use changes involved with cropland. Then Czech Statistical Office provides information of fallow land that is also involved in the estimates of emissions in category cropland. And then a very important resource is vector map of organic carbon content in soils on agricultural land. And these data we get from the Research Institute for Soil and Water Conservation, so that deals with soils in the country. So these are maybe I have some pictures which I can show you later on that. But so these are simply activity data that we use. Basically, what we do with cropland, we use 7 subcategories of land, the remaining cropland, which are listed. I think I will not go into the details. Basically, we have different types of agricultural land there, and these lands differ by its management. So what we have to solve is the conversion or changes of these lands from one to another. And this is again what we do with help of cadastral data. And depending on that, we apply different sets of factors that are associated with carbon stock change estimates. So then we use carbon stock from this vector map that we express as average for cropland at the level of individual cadastral unit. So, and apply the stock change factors that are different because of different cropland management involved with these different subcategories. And here the picture shows the extent of these specific subcategories within within category cropland, remaining cropland. As for conversion, that is land converted to cropland, again, we use the system based on cadastral information and carbon stock maps, carbon stock in soil, the maps of soil carbon simply that we have for different land use categories like cropland, forest land, grassland, and also based on them we estimate carbon stock map applicable to settlements. So basically, the source data that we have on soil carbon are those related to soil and cropland, but implicitly based on that we can estimate also soil carbon, grassland, and settlements land use categories. So the calculation on cropland land use category again involves carbon stock change in the pool of living biomass and soil. There is no dead organic matter. And conversion also includes that organic matter, because you can have conversion from forest, for example, when there is deforestation. So then we have to also estimate that organic matter. Then there is also some N2O emissions that is related to conversion of forest land to grassland and cropland, but this is a minor source of emissions, and we use IPCC 2006 guidelines to estimate that fraction based on simply quantities related to soil carbon stock changes. Let's move to grassland. Grassland, it's a part that covers 13% of the country currently. So it has some specific trend that is shown in the picture, and again, distribution within the country displayed by its share in cadastral units. The share is currently increasing mostly on account of cropland again. So cropland is converted to grassland quite often. So the sources are similar like those for cropland. There is land areas Czech Office for Surveying, Mapping and Cadastre, then Czech Statistical Office, which conducts farm survey, and then the Research Institute for Soil and Water Conservation that I mentioned when obtaining the map for topsoil organic carbon content. So the activity data that we use for estimating carbon stock change on land use category grassland, remaining grassland, this is basically subcategories of grassland that may differ by management type and intensity. So we use 4 subcategories of grassland that are displayed in the picture, and so the changes among them within cadastral units are the basis of estimates of land use change that concern carbon in soil pool. So in soil, so management and carbon in soil. This is basic source for carbon stock change estimation for grassland. So let me proceed to the picture of calculations that are involved. As I said, carbon stock change in soil, and then when we speak about conversion again, also that organic matter, because we can have also forest land converted to grassland. So there is also that organic matter and soil. Then we come to wetlands. They include all, let's say, water bodies and banks of the rivers, and as defined in our country, they cover slightly over 2% of the country. So you can see them displayed here. You can notify big rivers like Vltava here from south to north, and some other here in South Bohemia, a lot of ponds that are displayed by the dark blue color. So for wetland, we do not do much estimations for land remaining wetlands. There is nothing that we estimate. We just do estimates for conversion, because they relate to changes in carbon stock change and living biomass. Living biomass is, of course, removed when it's converted to wetland. So this is the assumption. The same for that organic matter. So this calculation is really simple. As for settlement, this is a category that includes all industrial surface areas and towns. So you can see Prague in the center, and then in the north there are coal mining areas that are displayed by this dark blue color. So currently over 10%, almost 11% of the country is covered by these brownfields and settlements, and it's increasing because of the population pressure. Again, we do not do estimation for remaining settlements, but only conversion from other land use categories to settlements, and they all involve all three major pools, and basically mean loss of carbon due to construction and built up areas. Finally, we go to harvested wood products, which is mandatorily required to be reported since 2015. So this is non-land use category. It's a contribution of the wood products that simply represents the changes in harvested wood product stocks. If harvested wood products are increasing, if the production is increasing, it means that the stock is accumulating more carbon, but generally it will respire later on using specific equations for respiration that are taken from IPCC guidelines. So this is nothing else than the default that we use. Basically, activity data we collect from FAO database, from FAOstat, and there the data are prepared already in the subcategories of sawn wood, wood-based panel, and paperboard, for which there are different decay constant applied, and so you can solve harvested wood products based on these activity data quite easily. This is the picture that shows the contribution of harvested wood products. You can see that in recent years, the contribution of harvested wood products is increasing because it relates to increased harvest a lot. So we don't do any change in default prescribed decay constants in the calculation. So let me move to the section of quality assumption, quality control. What we do is similar to what my colleague Anna Beranova has presented for agriculture. We basically provide internal technical control. We have some routine that includes filling the data spreadsheets and some specific reports. Then we cross-check our information on activity data with the other sources and data from Ministry of Agriculture and Ministry of Environment, and partly also we look, of course, on other inventories from neighboring countries. Then we have usually somehow more technically skilled person that looks into the spreadsheets that are used for the calculation, checking the errors from technical point of view. We can say that we also cooperate with the experts at the ministries regarding specific issues that they can help us with, and some assumptions on, well, not emission reductions, but we have several assumptions involved with some estimates for which we seek kind of official position of the ministry when it's needed. So that's my last slide. So I hope you are alive after this presentation, and we can start with the discussion if you feel for this.
Great. Thank you very much for the presentation. I think before we go to questions, I just wanted to ask for a little clarification on the cadastre. We were talking about this just to understand that it is a work in progress in terms of digitalization.
Yeah. Maybe I think that maybe Emil can add more about this digitalization of cadastral units. Yes. And the cadastral system.
Right, and then how you have managed to work with both the digitalized and non-digitalized data.
Yes, well, basically, the Czech Cadastral Office has the obligation to provide the information on all land units in the country. So they have data in different formats. But recent, let's say, I think since 19 no, since 2000 something, they started to digitize all the maps and data that they had that were only in analog forms. So now I think they are almost ready with entire digitalization of all land units in the country. So it's a huge effort that has been made, and so the data will be fixed and they will not change from year to year. If you would look into, for example, the area of the Czech Republic, sometimes that there has been discussion with LULUCF experts that our country changes in terms of area.
Yeah.
And some people would say, well, country cannot change because it's constant. So how can you speak that, and how can you say that a country area is changing? But it does change because we do not work with that country. We work with the estimates of the area of the country. And this is something else. And estimates are changing. So that's the reason.
Okay, great. Thank you very much. And now I think I'll hand over to Pavlina, and maybe you can summarize some of the questions in Skopje.
I think that today we will have questions directly from the expert team. So I will give the floor to the land use and forestry expert. Ljubča?
Thank you, Pavlina. Hey, everybody, thank you for the great presentations. As I can see, we are doing pretty much the same methodology of calculating these GHG emissions. The only problem with our estimation is the lack of data. We are we don't have such sure data about the forest land, about harvesting, about changes that are happening yearly. Most of the data that we are using is also from the forestry management plans, but they are updated every 10 years. So we are a little bit slow with that. How do you manage to update annually the data that you use?
Yeah, that's a good question. Basically, you can see that there is some asynchrony in the data because, as you said, we use the same type of forest management planning data, and that are updated every 10 years. But as you collect them across the entire country for different management units, it means that some management plans are very fresh and new, and some are almost 10 years old. So in average, the data on growing stock are in average 5 years old. But with this we can live because growing stock doesn't change much. The bigger problem is the estimates of harvest, which we have annually, and they are of course actual. For a given year we have annual estimates of harvest based on a very extensive, let's say, survey that conducts the Czech Statistical Office. So these data are really available at the country level every year, and this is very important to have when you want to use the default methods that solves the increment and loss, that is the default method. So yes, there is some small asynchrony in terms of having growing stock 5 years old data and the harvest basically 1 year old data or actual data, but this doesn't make much difference in the estimates.
Yeah, thank you. Well, forests are pretty stable ecosystems, I would say. There's no much changes except in a situation like you are now with this bark beetle and drought condition. And that is the similar in our country, but not with bark beetle because we don't have very much conifer. We have 90% broadleaf forests, but we have the problem with forest fires. And
Right.
if you chance to see the fluctuation of the GHG emissions and absorption in the forestry, you will see that it's very, very, the period of 2 events is getting shorter. So the second biggest problem is having illegal cutting. I suppose
Right.
you don't have such a big problem there. How do we estimate the illegal cutting, the number of cubic meters that are illegally cut, and including this? Because in this report, we don't have that. We don't have the data.
Mhm. Yes. I believe that for such conditions, it would be, of course, very good to have statistical sample-based forest inventory and use the stock change method, because then you would get the stock change really objectively, solving the stock in time 1 and time 2 and taking the difference. But the country of Macedonia is not preparing the sample-based national forest inventory.
No, we don't have. I think we are the only country in Europe that don't have forest inventory still done.
Mhm.
The last one was 30 years ago.
Mhm.
So it's a big problem. I also wanted to, yes, we had some project with FAO that we analyzed we tried to get the market of firewood, because this is the consumption method, and to see what the consumptions are asking for and what we are producing, but it came really big. So difference between what we are cutting and what we need to cut.
Okay.
These are very big numbers that I don't know how can we input into this, because we have to work with official data,
Right.
And
Right.
there
That's the
is no
point.
official-
Yes. That you Mhm. Yes. Well, I believe that both JRC and FAO, I don't know to what extent, but they have some resources to help countries like Macedonia that tries to develop and improve emission inventory. So
Yeah, we are trying for years. But, we adopted methodology, but we couldn't start
right.
the project. Okay, thank you very much.
Yeah. Welcome.
Dushko, do you want?
hear me?
Yes, we can hear you. But before you proceed, may I ask, there is one representative from the Ministry of Environment that would like to ask a question, and then you please just unmute and ask.
Hello to everyone. Thank you for the thoughtful presentation. I work in the Ministry of Environment and Physical Planning, and part of my work is dedicated to preparing of the emission inventory of the pollutant substances in the air. So I would like to ask the possibility of gathering data for preparing the inventory in the future. With the data that comes from the European Union, I mean for the data that belong to the Corine land cover and the Lucas data. My question is, do you sometimes use this data that comes from those two databases? And if no, do you compare the data that belong to only to your country? I suppose, as I heard from you, that you use mostly the data that comes from the cadastre of your country. And do you compare those three databases, and what do you think about the similarity, and do you recognize the many differentiations between those three databases? Because we have data from the Corinne land cover, and we also participate in the Lucas in 2018, I suppose. Thank you.
Yeah, thank you. Well, as for Corinne, when we started the inventory, we also analyzed Corinne land cover data for our country, and we partly used it for some estimates at the beginning. But then, in order to simplify our life, we turned to the cadastral data exclusively. So I recall that when we compared it, of course there are some differences, and Corinne had some problems, especially with resolution in 1990. That was really difficult. But in absence of other sources, if you don't have other sources, I think it's a fully recognizable resource of land use area data that you could use and develop matrix of land use and land use change based on Corinne. I know that there are some countries that use it. So, and currently there are also better remote sensing products, satellite products available also than land Corinne. So, I cannot tell you exactly what differences were between cadastral data and Corinne, but there were some differences, of course. But in terms of forest land, for example, the differences were not so big. I think there were more differences in agricultural land, but as for forest land, I think it was reasonably robust, this scoring system. In terms of Lucas soil survey, we also checked the data that were collected in our country partly, but we have fortunately better soil data available nationally. So we don't use Lucas data for our estimates, because the institute that I mentioned that provided us with soil data gave us basically better resolution soil sampling data than Lucas. But I know that European Union is really pushing Lucas into wider use, and maybe in future there will be harmonized sampling funded by EU, which we could basically also use for something, at least for verification of our land use or soil carbon stock changes. So we look on this development and see if they will be suitable for some estimates in our country too.
Thank you.
Thank you. Duško, the floor is yours.
Okay, thank you, Pavlina. Sorry, I couldn't find the icon for raising hand, so sorry for this. So many greetings to our colleague from Czech Republic. This presentation was very inspiring, but I will focus my discussion not just on a question, but more kind of a comment. This was very, very interesting and very, very inspiring for us. Obviously, that our colleagues are addressing almost all issues related to this complex land use change sector. But bottom line is that everyone is trying to do with what he has in his hands. Everybody is trying to find his own way. As far as I understood, our colleagues are relying on the data from the cadastral office, which is obviously very advanced, and they have data on the cadastral level of the cadastral units. But I didn't get how they do this conversion. I presume they have these spatial references like GS layers. In order to find what remains as a land in the same category and what is converting in the other land use. For us, this is a mission impossible because our cadastre does not keep such a records, and also we faced with the problem of historical data. So in our previous inventory, we did our inventory on the base on the Corinne land cover. But within this most recent exercise, we try to do this on the basis of the remote sensing data. So for these 30 years, we have processed photo interpretation of 15 years of satellite imageries from Landsat and Sentinel in the past few years, and that's how we come to some figures about land use and land use change. I am very aware that this is not the most precise way, but I believe that this gives us a comfort for a future better representation of the land. In the moment, we are just doing photo interpretation. Maybe in some later stages we can overlap with the soil factor and the climatic conditions, which are required according to the approach 3 method. I don't know if my colleague would agree with this, but we don't have other way to move forward, especially in data representing. And our also big obstacle is we don't have forest information system who will be in charge for doing the inventories and to do this forest management plan, gathering them, harmonizing of data, because forest is also for us a key source of emissions. And also my question, let's say my questions to my colleague would be, if they have land parcel identification system, I'm speaking now about the crop field. Is it possible? What is your opinion to rely on the land of the land parcel identification system and maybe on the future forest information system to verify this satellite imagery analysis and to come to some better representation of categories? And even more, the second question will be: do you consider the possibility to gather for the crop field a management data, how the crop fields are managed in terms of inputs, of how they are cultivated, irrigated, not irrigated, and whatsoever? Because it's very important convergence in emissions factor for the soils under cropland. Maybe I did it a bit complicated, but I don't want to take floor again. Thank you.
Yeah, understood. I think your first question, how you conduct currently your inventory based on your possibilities. Of course, I act as a reviewer under UNFCCC. I'm certified reviewer of inventories, and if I would be reviewing your country, I would just say, okay, you do what you can with your existing data, and it's perfect that you do the analysis of images of land cover. This is perfect. I mean, these data are the best you can have, and you will not have any better data from any land cadastre in the history, because that's already archaeology. Yes, that's the history. So if the system has not been working in 1990, then nothing else can be used than analysis of available images, flight images, either airborne or satellite images that you have available. So this work is perfect to have, and then it can be complemented, of course, with other resources. As for this forest information system, this is really strange, because I mean, you mentioned that you don't have forest information system, but there is certainly a ministry that collects the information on behalf of your country that should have the annually updated information on forest resources in the country in some way. So they should be collaborating with you to get the data in the structure that is needed, not only for emission inventory, but all kinds of reporting on forest for the FAO. In Europe we have this Forest Europe process that requires pretty detailed data for different kinds of assessment of sustainable land use under forestry. So there are a lot of protocols, international reporting protocols that require good data on forest resources. So there should be some kind of push to your ministry to devote some funds to improve data collection information from your country and build the system that meets the requirements for reporting, not only for emission reporting but also for the other protocols. And the other question was LPS system. Yes, we do have that. We use it for just the topic that you mentioned. That is, we collect data from LPS system on crops that are used in different parcels, and based on this, we derive the type of management that is used. So we use the expertise of agricultural colleagues that tells us what kind of management is dominantly associated with a given crop type, and based on this we derive for a given crop species or groups of species suitable emission factors on input and management and fertilization, etc. So that you know. So basically, LPS is used for this, getting improved management information based on what different crops require and how they are normally managed. I don't know if I have answered all the questions, but this is what I have.
Yeah, thank you very much. Thank you very much. We also have land parcel identification system in the past 10 years, but they do not get such a data, which is very strange. That's why I was asking,
But they don't have data on management, but they have data on distribution of crops. Yes, what crops are grown in different places and in different years. So based on that information, we collect the database on crops, on their areas, and then we link crops to the management types that is associated with different crops.
Yes, yeah. Thank you very much.
That would be all from our side. I don't think that there are any more questions. Does the colleagues from State Statistical Office maybe have some questions? No. Thank you very much from our side. I think that this has been very excellent sharing of experience with our colleagues. And if there are any more questions, we will send them by email.
Great. Okay. Anything you'd like to add?
No, I think that everything was said already.
Okay. Great. Okay. Thank you. So I think that pretty much concludes day one. And I would like to thank all of you for your participation, and particularly the experts from the Hydrometeorological Institute. And I think we will reconvene tomorrow at 9 a.m. with a little bit more of a sense of being in Prague and what you would be doing if you were here. So if you have questions or feedback on the format, please let Pavlina know. She can let us know. And otherwise, other questions you'd like to have for the speakers tomorrow, you can also share those via email or just tell Pavlina. And we will see you tomorrow. Thank you very much for your presentation, Mr. Chinchilla.
Okay, thank you.
Pavlina, any last
Bye-bye.
words before we say goodbye for the evening?
I think that would be it. I'm very grateful for all the effort that you have done over there in the studio, and to Positive and Jakub, and to you, Susan, especially, for making this all possible. But I'm really looking forward to meet you again tomorrow, everyone, because I think that this has been a first for many of us, the virtual study tour, but it has been a really extremely positive experience for everyone. And it showed that when there is will and where is determination, that results will inevitably come. So looking forward to continue our cooperation.
Excellent. We are looking forward to seeing you tomorrow. We will have IPPU and waste sectors, and we will also have quality assurance, quality control, and a few fresh news updates from the COP, thanks to our QA/QC speaker. So we can promise you some things you will not have heard anywhere else. All right. Thanks very much, and we'll see you tomorrow.
Bye.
So as Czech say, na starano.